Okay, here we have to sketch the two curves y equals 4 by x and y equals 4 by x squared, comma x equal to 6. That's the line. And so here I have drawn the sketch of these two curves and the line. The top curve is the curve y equal to 4 over x. The bottom curve is the curve which is y equals 4 over x squared, and the line x equal to 6. And so clearly this is the area of the region bounded by these two curves as well as the line x equal to 6. And to determine this area of this region, we can use the vertical rectangle as I have shown this in blue color. So this basically represents the rectangular strip, or we can consider this as a vertical rectangular strip, which we will use to determine the area of this curves and the line. And here we are going to use the area between the curves formula. That is area between curves. Let's say that the top curve is f of x and the bottom curve is g of x, and they are bounded between the limits x equal to a to x equal to b. Then the formula which we utilize is integral from x equal to a to x equal to b, and then the top curve minus the bottom curve, we can take its absolute value and dx. So basically this definite integral gives the area between the two curves. And so looking at this shaded region, we have only the line x equal to 6. And that means we know only the upper bound of this integral. We need to know the lower bound, that is the point of intersection of these two curves. And we can find it by solving these two curves. So let's solve these two curves to find the point of intersection. So let me consider the one of the curve, that is y equal to 4 over x, and the other curve is y equals 4 over x squared. So since both represents the same y value at this intersection point, I can substitute one of the y into the other y. So let me put this y into this y. So therefore it becomes 4 over x. Sorry, this is 4 over x, and this equals 4 over x squared. Now we divide both sides by 4, so we get 1 over x, and this equals 1 over x squared. We can do the cross multiplication here. So we get x squared equals 1 times of x is x. Now I subtract x and also do the factoring. So I get x squared minus x, and this equals 0. I can do the factoring, that is x times of x minus 1 equals 0. So we get two values of x, that is one of them is x equal to 0 and the other one is x equal to 1. So therefore this point of intersection is clearly x equals 1. So I just put this as x equal to 1. This is x equal to 1. And so now we can calculate the area between the two curves, or the area of the shaded region. Therefore we see that area between the curves are bounded by these curves, and the line is, and this equals, I put the lower limit of x which is 1 and the upper limit of x which is 6, and I have to put the top curve. The top curve is y equals 4 over x. This is the top curve, and the bottom curve is y equals 4 by x squared. So I put 4 by x squared and then dx. In case if we get negative value, we can take its absolute value. So let's find this integral. So I'm going to first find the integral of 4 over x. I can consider this as integral of 4 times of 1 over x. And integral of 1 over x is natural logarithm of x. So basically the integral of this expression 1 over x multiplied with 4 is 4 times of ln x. So I put 4 times of ln x for the first term, and we have to integrate the second term, which is integral of 4 over x squared, and this equals, I can factor the 4 and then rewrite this as x raised to the power of negative 2. And we can apply the power rule of integrand, and when we do that, we get x raised to the power of minus 2 plus 1 divided by the same number, that is minus 2 plus 1, and this gives 4 times of x raised to the power of minus 1 divided by minus 1. So this equals 4 times of negative 1 is negative 4. We can rewrite x power minus 1 as 1 by x. So therefore this becomes negative 4 by x. So basically the integral of 4 by x squared is negative 4 by x, which I put here. And then we have to apply the limits, that is from 1 to 6. So let's evaluate this. So this gives 4 times of natural logarithm of x plus 4 by x. And this has to be evaluated from 1 to 6. So this equals, let me apply the upper limit. This is 4 times of natural logarithm of 6 plus I replace x by 6. So therefore this is the expression we get when we apply the upper limit. Now we apply the lower limit for x. So therefore this becomes 4 times of ln1 plus 4 divided by, replace x by 1, so it becomes 4 by 1. Let's calculate this. This equals 4 times of ln6 plus I can simplify this 4 sixths as 2 thirds, since we have the common factor of 2 in the numerator and denominator. And 4 times of natural logarithm 1 is 0, because natural logarithm of 1 is 0. So this becomes 0. And then 4 by 1 is 4. So it is negative 4. Let's calculate this. We can put this expression into the calculator. And when we do that, we get approximately 3.83 units. This is approximately 3.83. The unit of area is, we can put this as square units. So this represents the area between the curves and the line. This is area of the region. Also, this is the sketch of the region.